Tonight, the time before time began, the universe, black holes, God and the laws of science. Professor Stephen Hawking, Dr. Carl Sagan, and Arthur C. Clarke discuss the mysteries man faces as he starts to explore the stars. Dreadful disabilities prevent Stephen Hawking from speaking a word, but he's risen above them to become a brilliant mathematician and teacher. Using a computer-driven voice synthesizer, he's told the world how the universe began, and now he's seeking the ultimate theory of how it works. Arthur C. Clarke invented the communication satellite long before the technology existed to launch one. That vision of the future fathered the global village. His novels and stories, including 2001: A Space Odyssey, have inspired a generation of real-life astronauts. Carl Sagan sent man's first messages to the stars aboard NASA space probes. He's sure we're not alone in the cosmic wilderness. Dr. Sagan joined our discussion from Cornell University in New York State, so I checked whether he could hear us over one of Arthur's satellites.
Yes, communication satellite technology is working very well, thank you.
Arthur, can you hear all right?
I can hear fine.
And Professor Hawking, are you in touch with Carl Sagan?
Yes.
Professor Hawking, in fact, has just made publishing history by writing a book about hard theoretical science which has outsold even Michael Jackson in the bestseller lists. It's called A Brief History of Time, and we'll be talking about the concepts that are in it. Now, Stephen Hawking is engaged in a search for the ultimate answer, a grand, unified theory that would explain everything. Stephen Hawking, that is quite an agenda. How are you getting on with it? Let me just explain that what happens when Professor Hawking wishes to speak. He lost his voice a couple of years ago and now has to use a voice synthesizer, and he can control a squeeze box in his hand, and on the VDU screen on the arm of his chair he's got a vocabulary which scrolls through, and he can pick out the words that he wants, and these words are then assembled into a sentence, and when the sentence is ready then he can process it through the voice synthesizer. So whenever you're ready, Professor Hawking, we'd like to hear from you.
In the last 300 years, we have discovered the laws that govern the universe in all but the most extreme conditions. I think there is a reasonable chance that we may find a complete set of laws by the end of the century if we don't blow ourselves up first. If we do find a complete unified theory, it will be a great triumph, not just for scientists, but for ordinary people as well. In time, the unified theory would be simplified and taught in schools, at least in outline. Then, everyone would have some idea of how the universe works.
Well, that is a tremendous vision. Now, Carl Sagan, you wrote an introduction to the book, and one of the striking things that you said is that it's only children nowadays who ask the big questions because they don't know enough not to.
What I was trying to get across was the notion that the school systems, it seems to me, have a attitude of discouragement of asking fundamental questions. If a 5 or 6 year old asks why the moon is round or why grass is green, the usual adult answer, at least in my experience, is to discourage the child. Say, what shape did you expect the moon to be? Square? Or what color did you expect the grass to be? Blue? Instead of saying that those are interesting questions, let's try to find out the answer, or maybe nobody knows the answer, and when you grow up, you'll be able to discover the answer. It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Excellent. Now, I have planned a reasonably finite structure for our little colloquium, and I'd like to start, if I may, with Professor Hawking. How did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past. In fact, one can show that all the galaxies must have been on top of each other about 15 billion years ago. This was a real Big Bang, not a puny thing that took place on the stock exchange a couple of years ago. It was the beginning of the universe and of time itself. Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, I'd like to stay with this basic proposition for the time being, the Big Bang theory. And to come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies, was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence.
Well, what I have in my mind is a picture that Carl Sagan had been leading me towards of the whole universe in quite amazingly small packages, like putting the whole world into a matchbox, as it were, immensely dense and immensely tiny. And in fact, so tiny it's kind of disappearing into a little point. Is this the earliest imaginable point that our minds are taking us to so far, Carl Sagan?
Well, as Dr. Hawking said, the galaxies are expanding, running away from each other. The further away they are from each other, the faster they are running away. If you run the cosmic movie back into time, you come to a moment, perhaps 15,000 million years ago, in which all the matter in the universe was touching in, if you like, a point. And a key unanswered and perhaps unanswerable question is where did all of that matter energy come from? What was before that? And if it was made from nothing, who made it? And who made the maker? And of course an infinite regress behind that.
Is the universe still expanding fast? I mean, is there a lot more room in space, as I think of it, for the universe to carry on getting bigger?
As far as I know, nothing in the way, and the expansion continues. The question is whether there is sufficient matter in the universe, matter that we have not yet counted, that will slow the expansion down, stop it, and have the expanding universe followed by a collapsing universe, or whether there is not enough matter to stop the expansion, and so the expansion then continues forever. This is an observational question which is still unresolved, and the Hubble Space Telescope, which who knows might be launched next year if we're lucky, might answer this question.
Professor Hawking uses a very striking metaphor of the Earth borrowing its energy from itself. Now, in straight banking terms, that means you're going to be overdrawn, and in the end there's going to be a collapse, a big crunch. So does Big Bang get followed inevitably by Big Crunch?
No, not inevitably. It depends on how much matter there is in the universe, which is a still unsolved issue. I should say that the prevailing opinion is that the universe will continue expanding forever, but that, in my opinion, is by no means a very secure conclusion.
Well, let me bring in the poet amongst us here. Arthur Clarke, you know what T.S. Eliot said, this is the way the world ends, not with a bang but a whimper. When you think of the end of the world, if you think of the end of the world, does it end with a bang or a whimper?
Well, one would like to think that we will end with a bang. Of course, we'll never know. It's rather a long way in the future. Some billions, tens of billions, possibly even much further in the future. And as Carl said, we may have the answers to these questions in a very few years if the Hubble Space Telescope gets successfully into orbit and can peer out to the boundaries of the universe.
If we are sort of living in a little suburb of the galaxy, can you foresee a time when we need to get out of the suburb and colonize somewhere else because of the gradual curve towards the end?
Well, I think the human race, if it survives the next few years, will go on to colonize first the solar system and then to send ships out to the stars and ultimately perhaps to other galaxies. But if the expansion of the universe is fast enough, we will never be able to keep up with it.
Now, one fascinating aspect that is raised is the question of time itself in the book. Now, we all think that we know what time is. It's a relentless march forward. But for the purposes of your argument, Stephen Hawking, you use a mathematical concept that you call imaginary time, which seems to be able to run backwards as well as forwards.
In our theories, there are two kinds of time. There is what is called real time. This is a kind of time that is measured by a clock. The time that we feel passing, the time in which we grow older. Then there is imaginary time. Of course, imaginary time is an idea that science fiction writers, like Arthur, have used in their stories. But imaginary time is also a well-defined mathematical concept. It can be thought of as a direction of time that is at right angles to ordinary, real time, in a certain sense. The universe has a beginning in real time, at the Big Bang. And it may well have an end if it collapses to a big crunch. But in imaginary time, it has no beginning or end. Rather, imaginary time is closed in on itself, like the surface of the Earth. The surface of the Earth doesn't have any beginning or end. I know, because I have been round the world, and I didn't fall off. Individual particles can travel through imaginary time and arrive back at an earlier real time. But I don't believe that people will ever be able to travel back in time, like in the film, Back to the Future.
I'm going to come first, if I may, to you, Carl Sagan, because this idea in Professor Hawking's book, this extraordinary four-dimensional model of the universe with no boundaries, but finite, just like the Earth. This, to me, is really stretching my own capacity for imagination to the utmost. How would you turn it into words for me, a layman?
Well, the first thing I would say is not to feel bad if it's not immediately, intuitively obvious. Our ability to understand things instantly, so-called common sense, derives from a certain range of size and speed and duration that are appropriate for human existence. We know about things from 1/10 of a millimeter to a few kilometers, from a fraction of a second to a lifetime, and so on. So when we are dealing with matters of quantum physics, where particles have a size of 10 to the minus 13th centimeters, or in cosmology, where we are talking about 10 billion light years or more, it is very reasonable that our intuition is not adequate to the task. One point I'd like to make about this is that every human culture has a set of creation myths, but they're in the realm of mythology or religion or folklore, and they are, of course, all mutually inconsistent. The great thing that is happening in our time is that we are able, through a method which can actually make some progress towards the real universe out there, to find out something about origins, and this is the scientific method applied to the science of cosmology. So I know that's not a direct answer to your question, but I thought it was more important to address the issue of feeling unhappy because it wasn't immediately understandable.
Well, yes, I find that extremely soothing, actually, because it is a kind of sort of formidable task of grasping this that makes me want to retreat into trivial questions like, is this idea of predicting backwards going to put astrologers out of business?
Nothing will put astrologers out of business.
Well,
Alas.
well, that certainly added a touch of lightness to these tremendous issues that we are discussing: infinity, black holes, and imaginary time. And at this stage, let's relax a little bit and have a bit of fun with mathematics at their most abstruse. I'm going to ask Arthur Clarke here to do some doodling with his computer and with a fascinating exercise with complex numbers, which is called the Mandelbrot set. Now, this is named in honor of a French scientist working for IBM. It's a mathematical equation which leads us towards the infinite. In effect, it makes the mathematics of the universe visual and incredibly beautiful. This is what we would see if we had eyes to see it, when order meets chaos. This is what's going on in the universe every day. An ordered universe is breaking down and becoming more disordered. This is the second law of thermodynamics in action, what Stephen Hawking calls Murphy's Law. Now, Dr. Clarke, you've been using your computer back home in Sri Lanka to explore the Mandelbrot set at incredibly high magnifications. Over to you, sir.
Yes, well, this strange-looking object is the Mandelbrot set, which actually is extraordinarily simple in concept. It's defined by an equation of just two terms, z squared plus c. That's all there is to it. Yeah, that simple equation, z squared or z squared plus c, you feed a number into it, then carry on over and over again, sort of cranking the number back round and round, and then plot the result on the screen. So I won't go into details, but this is the first appearance of this set. And what it does, it divides all possible numbers into two categories. It's really a map or a boundary or a fence, if you like, dividing one class of numbers from another. And you can tell your computer to go into any spot here and say, recompute that area to a higher degree of precision, and then blow it up on the screen. So you can use the computer as a microscope, and you can continue that process forever. Some of the images are incredibly beautiful and are going to have a great impact on artistic design in the next decade or so. I found what looked like black holes, and I'd like to show them to you. So what I'm going to do now, essentially, is to zoom into it, increasing the magnification manyfold. And if I press the right button, it should happen now. The computer will now give you this image, and I think you'll agree when it comes up, it's a very impressive black hole. And it'll be even more so when I start it into action.
Oh yes, it is magnificent, isn't it?
You ain't seen nothing yet. I should explain that this magnification, you remember the original picture, which it took about the same area. This time I've magnified it about 1,000 times. So the picture you saw first is now 500 feet across. Now let's see if this works. Now, isn't that lovely? So there is matter streaming into this black hole. Well, now, when I found this black hole, I started exploring the neighborhood, and I very quickly found another.
Indeed.
Now this...
That's lovely.
Now this is the second black hole. Now it looks just like the earlier one, but this is on a far greater magnification. The original Mandelbrot set now is, I think, about 10 million miles wide. This is enormously bigger than the first one you saw, yet essentially it's the same kind of pattern. This is black hole number 3, and this one took me 22 hours of computing the day before I left Sri Lanka. I had the computer running all night, and I'm rather proud of this one because on this scale, that original little picture you saw is the width of the orbit of Mars. So you understand that no human being has ever seen that particular pattern before, simply because of probabilities. And you can explore the Mandelbrot set by blowing up bits and pieces of it, and you're pretty sure that no one's ever seen that. You're the first person to see it.
And each time you're being drawn towards...
You're being sucked into it.
Mathematical infinity.
Into smaller, and yes, this is real mathematical infinity. This goes on forever and ever, limited only by the capacity of your machine and the speed with which it can do its calculations. I am doing calculations here. You may not be able to see that enormously long number, the 20-digit numbers or so, and the machine is multiplying those together hundreds of times a second. Now, the thing that fascinates me about this is that it is infinite in detail. You can go on forever and ever. Now, I would like to ask Stephen this question. Is the real universe also infinite in detail? I mean, we know we have molecules, atoms, electrons, protons, subatomic, right down to the quarks so far. But does it continue forever and ever? Or is there a limit? Is there a basement to the real universe?
Professor Hawking.
We will discover new structures when look at the universe on smaller and smaller scales. But in the case of the universe, there seems to be a limiting scale. It is called the Planck length, and it's about 1,000,000 billion times smaller than an inch. This means that there is a limit to how complex the universe can be. It also means that the universe could be described by a theory that is fairly simple, at least on scales of the Planck length. I just hope that we are smart enough to find it.
Are we smart enough to find it, Arthur?
Well, I wonder, because after all, we're still pretty primitive organisms, and the universe is very old. And I just don't know. I would like to think so, but then there's a feeling, when we found it, then what? Where do we go from here?
I'd like to turn our attention back now to Professor Stephen Hawking. Do you think that we could ever hope to use the old science fiction trick of diving into a black hole and then traveling to another part of the cosmos?
Some recent work indicates that particles that fall into a black hole can come out again from another black hole somewhere else in the universe. At first sight, this seems the ideal method of space travel. Just find a black hole and jump in it. But there are snags. First, there doesn't seem to be any way to choose where you come out. Worse than that, your history in real time would come to a sticky end as you were torn apart by the gravitational fields inside the black hole. Your history in imaginary time would continue out of the other black hole. But that might not be much consolation to someone being made into spaghetti. It would be like traveling on some airlines I could name.
So how do you see the actual role of science fiction? Is it purely escapism, or do you see it as having a very real purpose in broadening our patterns of thinking, opening our minds to the kind of vast concepts which we're discussing today?
Well, first of all, there's no objection to escapism in the right places. In fact, C.S. Lewis once remarked to me, the only people who object to escapism are jailers. And we all want to escape occasionally, but science fiction is often very far from escapism. In fact, you might say that science fiction is escape into reality. It's a fiction which does concern itself with real issues, the origin of man, our future. In fact, I cannot think of any form of literature which is more concerned with real issues, reality.
Well, what do you have to say to that, Professor Hawking?
I don't believe in stories of flying saucers and other unidentified flying objects. If time travel were possible, we should have already been visited by people from the future. I think if we were being visited by people from another time or another planet, it would be much more obvious and probably very unpleasant. I don't want to make contact with another civilization, except at a safe distance. It might be like the North American Indians making contact with the white men. I bet they wish they had never sold Manhattan.
I'll bet they did now. Carl, you are the world's leading expert in the search for extraterrestrial intelligence. Now, Professor Hawking doesn't want to make contact with them. Why do you want to make contact with them?
Well, first off, I would say we have little choice in the matter. That is, we have already announced, or rather I should say, Magnus, you fellows have already announced the fact that there is a low-level technical civilization in this part of the galaxy, because television programs get out at the speed of light. Since any other civilization who detects those signals is unlikely to be at or before our state of technological advance, since we've just invented radio technology, so to say, they are much more likely to be in our technological future. And the question as to whether their intentions are benign or otherwise is, of course, of interest, but we have nothing to say about the matter. So therefore, I think we might as well hope that it's benign if they're out there. From my point of view, The search for extraterrestrial life, and especially the search for extraterrestrial intelligence, is one of the key philosophical, scientific, and human questions that have been posed. But we are at the very beginning of searching. Surely it is important for us to know the answer.
One thing that interests me a great deal is the way in which the public perception of beings from outer space have changed over the years. They used to be the baddies, but now there's a sort of optimistic feeling that any extraterrestrial life is, if not benign, is at least not as hostile and aggressive as one used to fear. Is this the drift of your writing as well, Arthur, your thinking?
Yes, I'm an optimist, and I believe that any malevolent super-civilization would rapidly self-destruct, as we may be in the process of doing ourselves. So if we do have contact, physical contact with aliens, I think it will be benign.
My frivolous mind is much taken...
Very intelligent beings reasonably near. Why have they not visited us?
Well, that's a very good question. Let's throw it right across to Arthur Clarke.
There are literally dozens of answers to this. They may have come in the remote past. They may be visiting us every 10,000 years. I mean, the universe is a huge place, and even if there are fleets of survey ships going all over the cosmos, we shouldn't expect visitors less than, I'd say, every 1,000 years or so. They may know all about us, and they may have put a quarantine around our planet for pretty good reasons. They may be totally uninterested in us. They may be so much higher that they, we're just beneath contempt, if you like. You can speculate endlessly. I think we should just wait and try and get more evidence.
Maybe their space probes are saying there's no intelligent life on Earth.
They may have received our television programs and decided that that is the case.
May I attempt a different answer to Stephen's question?
Please do, Carl Sagan.
The first large-scale commercial broadcasting on the Earth was in the late 1940s. So that's, 40 years ago. So you must imagine a spherical wave expanding out from the Earth at the velocity of light, which contains all the dreary programs of the late 1940s. Since then, that expanding spherical wave containing the news of a developing civilization on Earth has traveled some 40 light years. Suppose that there are no civilizations closer than 40 light years. Perhaps they're not here because they don't know we are about just yet. But in time, the message gets to them, and perhaps they send a little expedition to look us over.
I was delighted when I read that when space probes went out, first of all, you put the figure of a man and a woman on the outside so that any alien life would recognize what we looked like. And then in a latest probe, I think you put in an LP of Earth sounds with instructions in hand signals on how to work the LP. How do you think anybody would have reacted if, in fact, alien intelligence had heard this LP?
My guess is that it'd be something like, oh, look, another artifact from some extremely primitive civilization. Which one is this? But then some degree of thanks that we were thoughtful enough to send a message into the far future, which could in no way benefit us, certainly a selfless act. And perhaps it would be recognized as a hopeful and optimistic gesture by an emerging civilization just setting foot into the great galactic wilderness.
Yes, Arthur.
I know what is going to happen to your voyagers, Carl. They'll be overtaken one day by a terrestrial spaceship and brought back to the Smithsonian.
It's certainly technologically possible, but I hope they let it go on its original mission.
Now, it's very nearly 20 years ago since man landed on the moon. Do you think that we've basically stopped trying to get man any further? Is there any chance that another Neil Armstrong will set foot on Mars in our lifetime?
The United States and the Soviet Union have managed to booby-trap the planet with about 60,000 nuclear weapons, with a little help from Britain, France, China, and Israel. A tiny fraction of those weapons is enough to destroy the participating nations, certainly the global civilization possibly, and the human species just maybe. It is now time for the United States and the Soviet Union to demonstrate that they can undo this specter, that they can demonstrate their ability to work together on high technology for peaceful, hopeful purposes that carry us into a benign 21st century. And that is why I support the idea of joint U.S.-Soviet cooperation in the exploration of Mars, leading up to an international manned, and by the way, womaned mission to the planet. Americans and Soviets, as representatives of the human species, other nations, I presume, would also be involved. And then a glorious, whatever it would be, few-month period in which Mars, I have a globe of it right next to me, in which Mars would be explored. There are hundreds, for example, hundreds of ancient river valleys on Mars. Mars is today bone dry. It was once much warmer, much wetter, much denser atmosphere, much more Earth-like. What were those conditions like? Why did an Earth-like planet get converted into this deep ice age condition that Mars has today? And is there life there? Could there once have been life? Are there fossil forms? There are extraordinary, enigmatic geological features on the planet. What is their nature? There's a huge amount of exploration to do, and all of it, every step that I've described, could be before the television cameras of the world, and we could all participate in such exploration.
Is another danger that the human bits that we take with us will pollute and destroy something enormously precious out there simply because we're so inquisitive about it? Arthur?
Well, as to the question, should human beings go to the other planets, I think the answer to that is, well, we could have stayed in Europe and explored America by robots. It might have been, it certainly saved a lot of human lives, but of course we didn't. We went there and lived in this new continent. Now, admittedly, Mars, in fact, none of the planets in the solar system is anything like as benign as the United States or the other parts of this planet. But one day, people are going to call them home. There will be Martians one day, and they'll be our great-grandchildren, and they'll think Earth probably is a horrible place in which to live. Now, as to whether we will pollute these environments, yes, to some extent. Of course, colonization always involves the destruction of what was there first. And I'm quite sure in the next century, in fact, already it started as a conference on the pollution of space planned in the United States in the very near future. This is already a serious problem in near-Earth space. But we have to control it. I mean, you have to cut down forests on this Earth to make new cities, and on the Moon, I'm afraid one day we may have to abolish much of the lunar vacuum, and on Mars we may have to change the atmosphere. But I do hope we will leave bits of the universe in a pristine condition.
But are we also going to have to change ourselves on Mars? I mean, are we going to have to evolve differently?
Mars will change us. In fact, this is part of the evolutionary progress. By going out into new environments, by occupying new biological niches, that is the way we progress and discover the universe and explore and perhaps fulfill our destiny.
Do you think that other planets might have the same kind of system in which there would be a morality, in which there would be people taking moral attitudes, which may not necessarily be the same as ours, of course?
Well, all societies must have some moral structure. I mean, otherwise you just can't have a society. I mean, there must be understand rules, the way you behave to our neighbors. And even if the societies consist of machines, they must have a machine language so they can agree to react together. So morality in some way is essential and universal.
Now, Professor Hawking, in the very last paragraph of your book, you say that if we discover a complete theory of the universe, then it should in time be understandable in broad principle to everyone and not just to a few scientists. And when that happens, all of us will be able to start discussing the why rather than the how. And I quote, "If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God." Do you think that God can intervene in the universe as he wants, or is God too bound by the laws of science?
The question of whether God is bound by the laws of science is a bit like the question, can God make a stone that is so heavy that he cannot lift it? I don't think it is very useful to speculate on what God might or might not be able to do. Rather, we should examine what he actually does with the universe we live in. All our observations suggest that it operates according to well-defined laws. These laws may have been ordained by God, but it seems that he does not intervene in the universe to break the laws, at least, not once he had set the universe going. However, until recently, it was thought that the laws would necessarily break down at the beginning of the universe. That would have meant that God would have had complete freedom to choose how the universe began. In the last few years, however, we have realized that the laws of science may hold even at the beginning of time. In that case, God would have had no freedom. The way the universe began would be determined by the laws of science.
Well, thank you very much. And Carl Sagan, in your introduction to the book, you commented on this. You said this is also a book about God, or perhaps about the absence of God, because Hawking left nothing for a creator to do. Now, God, of course, means many things to many people. What sort of God, basically, are we talking about when we talk about reading the mind of God?
Well, I think that's an excellent question, and I'd be most interested to hear Stephen Hawking's answer. But just to try to illuminate the range of possibilities, consider two alternatives. One is the notion popular in the West of God as a sort of outsized, elderly white male with a long white beard sitting in a throne in the sky and tallying the fall of every sparrow. Contrast that with the idea of God in the mind of, let's say, Spinoza or Einstein, which was, at least very closely, the sum total of the laws of the universe. Now, it would be madness to deny that there are well-defined physical laws in the universe. And if that's what you mean by God, then there's no question that God exists, but it's a very remote God, what the French call a roi fainéant, a do-nothing king. On the other hand, the former model, the one who intervenes daily, for that there seems to be, as Dr. Hawking said, no evidence. I think it is wise, my own personal feeling, to be a little humble on such matters. We must recognize that we are dealing with, by definition, the most difficult things to know, the furthest from human experience, and perhaps we will be able to penetrate a little way into these mysteries.
I think, Professor Hawking, you'd like to come in here.
I use God in the same sense that Einstein did. It is really the reason why the universe is as it is, and why the universe exists at all.
Can I ask Arthur Clarke what he meant when you're alleged to have said to the papal nuncio, "I don't believe in God, but I'm extremely interested in him"?
Well, I guess I haven't placed my bets yet. And, you know, Stephen's remarks and Karl's remarks reminded me that this was said 200 years ago when Napoleon, I think, was talking to Laplace, who published his theory of the universe. And Napoleon said, God isn't in it. And Laplace replied, "Sir, I have no need for that hypothesis."
Do you think that the Church is, in fact, beginning to recognize that it may have to lose its priority, its eminence as the sole arbiter of these matters, and that science will be allowed to come in as an equal partner?
Well, the Church is certainly, when I say the Church, the Roman Catholic Church has become very much more liberal. I had the pleasure of giving a talk in the Vatican myself in the Pontifical Academy of Science quite recently and met the Pope. And of course they're reinstating Galileo, and so things are moving.
In fact, are they moving backwards as well as forward, Carl Sagan? Because I understand it in the earliest days of civilization, then the priests were in fact what we call the scientists, the ones who could study astronomy and who could predict eclipses and things. Do you see the scientist coming back into an almost sacerdotal position like this, or am I overstating it?
Well, I hope you're overstating it. I think the essence of the scientific method is the willingness to admit you're wrong, the willingness to abandon ideas that don't work, and the essence of religion is not to change anything. The supposed truths are handed down by some revered figure, and then no one is supposed to make any progress beyond that because all the truth is thought to be in hand.
I'm really talking about setting
Please.
an agenda for the future.
My sense is that the scientific way of thinking, questioning, some delicate mix of creative encouragement of new ideas and the most rigorous and skeptical scrutiny of new and old ideas, I think that is the path to the future, not just for science, but for all human institutions. We have to be willing to challenge because we are in desperate need of change.
Can I put the same question to you, Arthur Clarke, then? Politicians or priests are setting the agenda, or scientists?
I'm very fond of quoting Pandit Nehru on this when he once said that politics and religion are obsolete. The time has come for science and spirituality.
I hear from the clicking that Professor Hawking would like to come in.
I don't think that physics tell us how to behave to our neighbors.
Ah.
Well, physics may determine who our neighbors are and on what planets they live.
Well, you said science should be skeptical of politics. Don't you think we ought to be a little skeptical about science too? I mean, can we trust you guys?
I think you should certainly be skeptical, but my view is that there's no community of people on the planet more skeptical than science. It's our stock in trade. It's the lifeblood of our subject.
Science is a self-correcting subject, not like politics.
Well, politics is corrected by other forces. Can I ask one question of you all, and that is the question of creativity, which fascinates me. Here we have three enormously creative people with enormously creative intellects. How, in fact, does it operate? Do you, Arthur Clarke, do you sort of find a problem that you'd like to work on and then look for a solution to it?
I'm not sure what my mechanism of creation is, and I don't think I really want to know, because I'm afraid that if I discovered it, I would be like the centipede when it was asked how it walked, just fell distracted in a ditch.
Or a golfer when he's asked about his swing, yes. So you don't think about that. Carl Sagan, there is a serious side to this.
Well, this issue of where creativity comes from is, I share your fascination with it. I don't think we understand very much about it. My practice is merely to respect my unconscious mind, who often is much wiser than the conscious part of me, and pay attention to what it says. In fact, I think this is connected with that delicate tension at the heart of the scientific method I talked about before. The unconscious mind proposes a range of possibilities, and the conscious mind disposes, that is, compares those ideas with the real world, checks for internal inconsistencies, and so on. I think the creative process is a partnership between a conscious and an unconscious part of our minds. At least that's how it seems to me.
I'd like to leave the last word on creativity, in fact, with Professor Stephen Hawking. Just whenever you're ready, sir.
I am just curious. I want to find out how things work. I follow my nose. One thing leads to another, and I don't know what I will find next.
Now I think I would like to retreat a little bit into poetry myself, because it's nearly 150 years ago since Matthew Arnold wrote his splendid poem, The Future. But what was before us we know not, and we know not what will succeed. Well, perhaps if Professor Hawking's magnificent vision and curiosity is realized, we'll have proved Matthew Arnold wrong before the 150 years are up. Gentlemen, to all of you, to Professor Stephen Hawking, to Dr. Arthur C. Clarke, to you, Carl Sagan in America, our warmest thanks to all three of you. And to all of you watching, good night.